Alright, so here we are with the 5.7 notes for geometry. We're going to talk about the Pythagorean Theorem and kind of using it as its own function, but then also to identify what type of triangle we have. So, we're going to use the Pythagorean Theorem and its converse to solve problems, which just means if, rather than here's the formula, use it, it's going to be can you use it and see if it fits the formula. So, and then we're going to use Pythagorean inequalities. We're going to have less thans and greater thans and things like that to classify a triangle as either obtuse or acute, etc. Alright, so first thing that we're going to talk about is a Pythagorean triple, just so that we can kind of see what that is. So, in order to get to a Pythagorean triple, we need to actually know the formula, so hopefully we remember the formula of a squared plus b squared equals c squared. Now I know the first time I learned this, anytime that I saw the a, I always thought that had to be the smallest or something like that, but it doesn't. A and b just have to be the sides, and it doesn't matter if one of them is bigger or not. We also call them the legs, either way. So this is a leg, and this is a leg, and then of course our other piece is what we call the hypotenuse. And that's always the c value. The hypotenuse is, of course, always across from the 90-degree angle because it's the largest side, and that's the largest angle, so it's going to be across from it. So, what we do again is take the length of the leg, square it, take the length of the other leg, square it, add those two together, and then set it equal to the length of the hypotenuse squared. Which means that if we're solving, we'll probably end up using a square root to undo a square. So, taking a look at our first example here, they just want you to go through the idea. So, this is a leg, and so all we need to do is identify that this could be A, this could be B, and this could be C. And so in our formula of a squared plus b squared equals c squared, A would be 6, B would be 2, and C we don't know, but we know whatever it is squared. Filling that out, 6 squared is going to be 36. Don't know why I was going to write 16. And 2 squared is 4, and so c squared is going to be 40. But of course that's not the end. We're trying to get c by itself. We want the actual length. So we undo the square by doing a square root, and then the square root of 40 ends up being our solution. So the square root of 40 is 6.3246, something like that, and so that would be the length of the hypotenuse. Another example here is, let's say that we wanted to put in a variant of the hypotenuse. So this is saying, oh, if you take the hypotenuse length, whatever it is, and subtract 2 to it, you're going to end up getting that leg length. So it's the same idea, however, even though there's a little bit more algebra involved. This is still going to be one of our legs, this is still another leg, and then this across from the 90 degrees is still our hypotenuse. So if we use our Pythagorean theorem, we've got x minus 2, which will be squared, and b, which is 4, which will be squared, and that is going to equal c squared. This is where we have to go back to understanding how to multiply out or expand a polynomial. And so we can't just say this is x squared minus 4 or something like that, because that's not actually how you would expand x minus 2. So a little side work here is that if we use the box, we actually have x minus 2 and x minus 2 expanded to get an x squared, a negative 2x, another negative 2x, and a positive 4. So this binomial squared is actually x squared minus 4x plus 4. So x squared minus 4x plus 4 plus 16 from the 4 squared is going to equal c squared. Continuing on, we would combine anything that is a like term. So 4 and 16, oh, and that's not a c anymore, that should be the x. didn't plug it in. Alright, and so 4 plus 16 is going to be 20, so we have x squared minus 4x plus 20 equals x squared. Interesting part about this is that we can actually subtract our x squared over here and realize that a positive x squared minus an x squared is going to just leave us with negative 4x plus 20. So most of these, what's going to happen when you have a variable is that the squared variable will cancel. So moving on, if we, for instance, subtract the 20 over to the other side, we'll end up with negative 4x equals negative 20. Divide both sides by negative 4, and we realize that our x is 5. And so again, this was our side problem here. All right. Next one here, this is very common when it comes to especially standardized testing and things like that, or placement tests. So the idea here is that there's a ladder, because of course there's always a ladder leaning against some sort of building or house or something. And so the idea here is that there's a safety ratio of 4 to 1, because you do not want to have your ladder too low, because it'll actually slip because there's not enough grip. And then you also can't have it too steep either, because you end up falling backwards. So there's these safety regulations of how much of an angle you can have. So in this case, our safety ratio is apparently 4 to 1. And so you have a 30-foot ladder, so we haven't mentioned that, but here it is, a 30-foot ladder. And how high will a 30-foot ladder reach when it's placed against a wall? This safety ratio is saying 4 of this height and 1 of this base is what we want to have. So we're saying that in our triangle, if this is 30 for the hypotenuse, 4 of some value and 1 of some value are going to be part of the ratio that will make this safe. So, of course, we have two x's involved, but that's okay. This is going to be our c value, and then these two legs are going to be a and b. And so if we take our Pythagorean theorem, we fill in our a of 4x, our b of 1x, and it's this quantity squared, so I don't want to keep that. And then the last one is our c squared, so 30 squared. If we solve this, 4x squared is actually going to be 16x squared, because that squared goes to both of those values. Technically the 1 is squared as well, so 1 squared x squared, but really 1 times 1 is just 1 again, so x squared. And then that's going to equal 300 squared, which is 900. Alright, so to simplify this, we can take our 16x's and 1x squareds, put them together and make 17x squareds. And then solving algebraically, we would divide by 17. And we'd get an x squared equal to 52.9412. But, of course, that's an x squared, which is what we don't want. We want an x. And so the x value is going to be the square root of that 52 number. So 7.2761. And it was feet when we were talking about the ladder, and so we're going to say it's about 7.3 feet. How high will a 30-foot ladder equals x? But, of course, this was supposed to be 4x. So we need to multiply by 4 in order to solve the problem. So 7.3 feet times 4 to see the height. I don't know why I used an old school multiplication symbol. Alright, and so 7.3 times 4 means that the height on the wall is 29.2 feet. So this is what I would call our almost answer, because most of the time you feel like once you get x, you're done. But of course we need to plug it into the problem, which said how tall will this ladder end up reaching, and it's 29.2 feet. So that's kind of its maximum safety angle. Alright, so the next one, Pythagorean theorem here, we're going to understand what a Pythagorean triple is. So the biggest thing is that it's a whole number, okay? So Pythagorean triple is whole numbers. Notice all here, whole numbers, no decimals. The other thing is that it is a set of non-zero, because 0 can't be the length of a side, values that can be used in this. So if it works in the a squared plus b squared equals c squared, and it's a whole number, then it becomes a Pythagorean triple. So for instance, 3, 4, 5 is a Pythagorean triple. It's a very common one. So the idea would be that 5 would be c because it's the biggest one, and a and b would be 3 and 4. So if I just check that this works, we're saying that a squared plus b squared equals c squared, and they say a could be 3, b could be 4, and c would have to be 5, and we're seeing if it works. So we're saying, is 9 plus 16 equal to 25? And it is. So I could, work through all the rest of them, but they do all work. So 5, 12, 13 is also another recognizable one. 8, 15, 17, and then also 7, 24, 25. Another interesting part about this is that you can get every other set of Pythagorean triples by multiplying one of them by a value. So let's say that I took this one and multiplied by 3. Another set is going to be 7 times 3, which is 21. 24 times 3, which is 72. And 25 times 3, which is 75. So again, all I did was multiply by 3, and now I have another set. So you can multiply by any whole number, and you get another set of Pythagorean triples. So there's an actual infinite amount. Just a smaller infinite amount, however, than an infinite number of numbers. Anyway, sizes of infinity. Alright, so this next one here, we're going to find the missing side length and tell if it's a Pythagorean triple. Well, how do we know? We need whole numbers. So if the answer to this here is a whole number, then we can go ahead and say that it's a Pythagorean triple. So either way, we are knowing that's our c value. We also know that this could be a and this could be b. So we just put it into our Pythagorean theorem. And we don't know what c is, but we'll get there. A is supposed to be 14, b is supposed to be 48. And so 14 squared is 196. 48 squared is 2,304. If I add those together, we get 2,500. And take the square root, and we get 50. So since c equals 50, is 50 a whole number? Yep. And so we know the missing side length is 50, and we also know that it is a Pythagorean triple set. So again, 14, 48, and 50 are a Pythagorean triple. Whoops. And how would I know that would even happen? If we go back to the previous slide, all I would do is take this one and multiply by 2, and I'd get 14, 48, and 50. So hopefully you saw that linked. Alright. The next one here, we're supposed to find the missing side length and tell the side length form of Pythagorean triple. Well, remember Pythagorean triple is whole numbers. And so I can already see that this is not a whole number. Because of that 2.4. But it does also want us to find the missing length, so we will go through and find that. So a can be 1, b can be 2.4. And so if a is 1, 1 squared, and 2.4 squared is going to be involved. So 5.76 is it squared. So 6.76 is going to equal our c squared. And so we'll take the square root of both sides. and get 2.4. So again, even though this side does kind of get what we call a terminating decimal or something that ends, it's not a Pythagorean triple because of decimals. We can't have decimals, so gotta watch out for that. Alright, then the last thing that we're going to do with the Pythagorean theorem here is we're actually going to, as much as we love seeing it as a squared plus b squared equals c squared, we're actually going to think of it more as c squared equals a squared plus b squared. Because then we'll be able to very quickly, I'm going to write this down, c squared. Because then, if we get a greater than sign, when we plug in some lengths, we're going to get something that's obtuse. When I think of something that's greater, I think obtuse or larger, so that makes sense. Versus if we get a less than sign, we'll think of something acute or smaller and know that that's an acute triangle. So we can use the Pythagorean theorem kind of as a center, because the center of if it's equal is at 90 degrees, right? But if your c squared is less, then you end up getting an acute triangle. But if your c squared is greater, you're going to end up with an obtuse triangle. So 90% is kind of that center, or 90 degrees, sorry, if the theorem works exactly. But then if you have a less than, it's acute, and a greater than, it's obtuse. So basically what you need to know is which number is bigger, because that's always going to be c. So the biggest value is c. And so we'll apply it in a problem here. So by the triangle inequality theorem, which is what we have on the previous side, because it's got inequalities saying if it's obtuse or acute, the sum of any two side lengths of a triangle is greater than the third side length. Because remember, this needs to happen in order to have a triangle exist. Because remember, if the two sides are less than the third side, then we can't actually even make a triangle. So first we're going to check if it's a triangle. And so how do we check if a triangle can happen? We need to know that 5 plus 7 is more than 10. And 5 plus 7 is 13, and 13 is more than 10, and so a triangle does exist. So now that we have that part down, then we can go through and actually use our c squared idea. And is c squared either equal to, greater than, or less than a squared plus b squared? Well, c is going to have to be the 10 because it's the largest, and a and b can be the 5 and the 7. So if we plug in our values, we're going to have 10 squared, and we're seeing if that is equal to, greater than, or less than the 5 squared and the 7 squared. So continuing to fill in this box, 10 squared is 100, and we're seeing if that is equal to, less than, or greater than 25 plus 49. So is 100 less than, equal to, or greater than 74? And it turns out that it is less than, or sorry, greater than. And so because we used greater than, that means it's a obtuse triangle. Okay, so just so that we're aware, again, we check to see if a triangle could actually occur. Yes. Then we put it in this idea of, is c squared bigger than a squared plus b squared? And it is. And so now it's obtuse. If it was less than, it would have been acute, and if it was equal to, it would have been right. Alright, so we're going to do the same thing over here. The first thing we need to do is check if a triangle exists. And so we need to take our smaller two sides, which would be 5 and 8, and see if that is bigger than the larger side. Okay, and so 5 plus 8 ends up being, what is that, 13? And 13 is not bigger than 17, and so this triangle doesn't even exist. But again, if it did, you would have gone through and said, 17 squared, is that equal to, greater than, or less than 5 squared plus 8 squared? But of course we couldn't do that part because the triangle wasn't possible. Alright, so that is our 5.7 notes. Kind of a lot to go through, but I know that you have seen the Pythagorean Theorem, so just understanding how to use it, and then know what a Pythagorean triple is, your whole numbers, and then also that inequality to find out if something is greater than to be obtuse or less than in the Pythagorean Theorem to be acute.